Assalamu alaikum. Hello, everyone. Today we continue our lectures. We are still in the topic of basic programming concepts. Before we go and pick up from where we left off last time, I would like to mention a few things I forgot to mention last time. So I will start with this here. So as you can see here, so we are actually doing reassigning here. Okay. So because if we run this, if I run this like this way, so then the change will be temporary. Okay, so I have to reassign it to another variable or to itself. Okay, that's why we have this. Like we say, like this, yeah, this df of c1 is equal to df of c1 dot apply the function. Okay, because here apply doesn't take in place equal to true as an input argument, so we have to do reassignment. Okay, if we don't do reassignment, then that change will be a temporary change. So it has to be stored somewhere. Otherwise, it will not be a permanent change. So it has to be either, as I said, if we are changing the column itself, then we need to assign it to the column. Okay. So the new version of this, or the C1 after the change, is equal to C1 dot apply this. Okay. That's one thing I wanted to mention. And also there was another thing here. Here, yes, this was the example was exclude equal to object, if you remember. Okay. So if we run this here, okay, this is the data. There are like this much of object type attributes, and there's this much of integer attributes. Okay, so here when we wanted to extract the numerical columns, we passed this parameter exclude equal to object. So we are excluding the object once. So we are let me just comment this. We'll come to that later. So we are extracting only the numeric attributes. Okay, we can do it in another way. We pass the parameter include, and here we pass number. Okay, this will extract all numeric columns regardless of the type, integer or floating point. Okay, so it will extract all numeric attributes. If I want only the integer ones, so here is the data type, as you can see, because here we are selecting data type that matches this. Data type is here, you see, integer 64, then we are extracting only the integer ones. And in fact, all of them are integer. That's why we get the same result as if we pass number. If we do float 64, there will be nothing there. Okay. So yeah, we can do it this way or exclude. So in order to know about, because we don't always mention like all like arguments that we can pass to any function. So if you want to know more about any function, you just need to run help. Okay, help, and you pass this the function here. Okay, here df dot select data type, and then you can look at the help and what are the different parameters you can pass. For example, here there's include, exclude. Okay, and also here like the type include can take a Boolean type, floating point, integer. Exclude the same thing. Okay, so these are examples here. Okay, so you can, as I said, you can take number as a value, and it will extract all numerical attributes. Okay, yeah. So another thing, last thing I want to mention here. So yeah, those kind of a plots, histoplot, counterplot, all of these are axis level plots. That's why we like here we define the figures using like we create the figure. Okay, and then every one of these, like for example, if I want to plot, so they do not really create a new figure. That's what I want to say. So if I take this outside here, okay, okay, and this is take it here, and I can actually now I'm plotting every column, not in a new figure, all of them in the same figure. So this is what we get here. You see, all of them on top of each other. These are axis level figures. Okay, they do not. So that we have axis level plots, and we have figure level plots. These are axis level plots. So they do not really create a new figure for each plot. Okay, so they are just using like the given axis and generate the plots. Okay, that is these are the few things I wanted to mention before we start today's lecture. Okay, so we did this last time. We did this as well. So I think we stopped here. Okay, so we're going to draw the box plot for all numeric columns for each one of them, differentiated by another, the value of another categorical attribute. Okay, so first of all, first of all, let's just plot the box plot of every numeric attribute. This is the box plot. These are the statistics for each numeric attribute. We've done that in the past. Okay, here we're just calling the box plot function inside the Seaborn library. Okay, y is equal to the column name, so we are plotting them this way vertically. Okay, so we are plotting the box plot for everyone. So these are the statistics of everyone. Okay, now I want to plot the statistics of every attribute, but differentiated by the value of this categorical attribute called test preparation course. Test preparation course has two categories. Okay, either none or completed. So the student or the person either have completed the course, have taken the course, or it has not hasn't taken any course. Okay, so there are two choices for this categorical attribute. So when we say we are plotting the statistics of a numeric attribute differentiated by the values of this, what's that supposed to mean? It means like we are actually splitting the records, the data, splitting that as to a number of subsets as many as the number of categories in this one. And then we are plotting the statistics of every subset separately. Okay, so we plot the statistics of the ones who have taken the course separate from the ones who haven't taken the course. Okay, so that's what we get here. So we are generating two box plots because x is equal to the value of this. And for this, there are two choices, none or completed. As you can see, so we are plotting the statistics of the ones who haven't taken the course separate from the ones who have taken the course. So we can see the effect of taking the course here. Okay, so if you look into these two box plots, you see like taking the course is beneficial somehow, right? This is for the first one, for the math, because we are doing that for every numerical attribute. This is for the math. So as we can see here, taking the course is somehow beneficial. So the median is higher, and at least there are less outliers here. There is a shift. Okay, not that much, but there is difference. Okay, the median is a little bit higher, and there are less outliers from the bottom. Okay, so here, in fact, here taking the course is more beneficial. It seems like it has a higher effect here. The median is is more higher, and there are no outliers from the bottom. So this is the kind of conclusions you can make. Okay, you're looking into different figures. Here is even higher. Okay. Okay, so that is the that's how you plot the statistics of a numerical attribute differentiated by the different choices or categories of a categorical attribute. Now we come to another useful plot, which is a scatter plot. Scatter plot is usually used to plot the relationship between two variables or attributes. So by visually looking at the scatter plot, you can tell if there is any pattern or if there is any relation between these two attributes. Okay, If there is like if the dots are all over the places, then most probably these are not correlated and there's no any relationship between these variables, okay? But if there is some kind of pattern, then there is a relationship. Let's look at this. First of all, this is the syntax of the code. So we call scatter plot. So here we're plotting in the x-axis the total score, in the y-axis the math score. The color of every dot is red, and we are adding a legend here. So the label is equal to math score. Alpha equal to 0.5 alpha is just to define the transparency of the dots, okay? Because sometimes there are overlapping dots. So introducing some transparency can show you like all the dots. So, and we're taking the data or these columns from this data frame. Okay, we do the same for the relationship between the total score and the reading, total score and the writing, and that's it. So let's look at this. Okay, so there's an error here. What is it? Oh, we forget to run this code here. Let's do it. Where is it? Yeah, we forget to run this. Let's run from here. Okay, this is it. Okay. So the screen is now okay. So we clearly see in average, there is a clear linear relationship between the total score and every one of these scores. Okay. There's a clear linear relationship. As each one of them is increasing, the total score is increasing. So they are all increasing somehow together. So the one who scores good in math scores good reading and writing, and scores and the total is increasing. Okay, so that the total is linear with respect to every one of them. Okay, that's one thing. So there is a trend here. Okay, we clearly see that there's a pattern. There's a linear relationship in average. Okay, that's one thing we observe. Here, as I said, alpha, if I put alpha 0.1, it will be much more transparent. Okay, you see, if I put alpha equal to 1, there will be no transparency. Okay. Okay. As I said, scatterplot is very good in uh, finding, like visualizing, like extracting any information about a relationship between two variables. If these dots were all over the places, then most probably there is no correlation. There is no any kind of relation between these two variables. And we'll see more later in the next topic how that is useful as a tool like for data visualization and preparation before performing any machine learning task. Okay. Uh, okay. So now we come to the next thing here. Here we are plotting the scatter plot of the math score versus the writing score, and the size of those dots is controlled by the total score. Okay, and we are defining set of sizes. These are sizes, these are not the values. Okay, so alpha is equal, let's put alpha equal 0.5 here, and let's look at this plot here. Okay, as you can see, this is the relationship between the math score and the writing score. Okay, it's a linear, and the size of the dot itself is controlled by the amount, the value of the total score. So if the value is 50 or less, then this it's as small as this one. If it's greater than 50 up to 100, then the size will be this one, and so on. So we can look, for example, at a specific point here. For example, this is less than 50. Okay, it's very small dot compared to, for example, this one here. It's a very large dot here. Okay, we can actually, if we don't define these, our sizes, it will take the default ones, but maybe they will not make a big, that much of differentiation. Okay, so yeah, so they are not, so we are specifying our sizes. I don't remember what the unit is here, but these are for the sizes of the dots. Okay, I think we can also do it with the hue. Okay, okay, but then here, since it's like continuous range, it will, we don't define color or anything. Then maybe, yeah. Why it's not taking that? Okay, sorry. What I did say. Okay. Hue is equal. Hue is equal to the total score, and we remove this. We still remove this. Okay. And yeah, here we are differentiating by the color here. Okay. I think we can specify our own colors. Okay. I think we'll see something about this later on. Okay. So that's the math score versus the writing score differentiated by the total score. So the total score is given different colors, though this set of colors are not so different, but I think there is a way to define, like we pass our own colors. Okay, we'll see that later. Okay, let's just okay. Okay, let's go to the next one here. This one is interesting one. So here we are creating new columns. Each column here, the first column here is the difference, the absolute difference between the math score and the reading score. Each one of these is a series, but we still can call the numpy dot absolute function in order to take the absolute difference. Okay, so if you print the type of each one of these, it's a series. Okay. So we're taking the absolute difference between the math score and the reading score, and we're creating this new column. That's the difference between the math score and the reading score. The next one is the difference between the math score and the writing score. And the next one is the difference between the writing score and the reading score. So we are creating these three differences. Okay. Then we are plotting, like in x-axis, the total score versus all these differences. Okay, so this is a bit complicated way to do it. This is a simpler way, but let's explain this first, the complicated way, and then show the simple way. Okay, so here at very high level, what we are doing, okay, so we are selecting these numeric columns here. Okay, and we are creating a new data frame from this slice, all the entries of these numeric columns. So we're creating a new data frame that contains the content of these four columns. Okay, the three differences that we created and the total score. So we're creating a new data frame from that. Then we are using the content of the total score as the index of the new data frame. Okay, so we can do that. So for the new data frame, we take this column, and we are using the values of the elements of this column as the index. Okay, the default index is 0, 1, 2, but here we are overwriting that default choice of the indices. So we are using the content of this as the indices of the entries. Okay, and then we are sorting these entries, because we are gonna plot the total score in the x-axis. So we need those values to be sorted, okay, according to the value of the total score. So we are sorting all the entries, okay, and then we are using the function line plot. I will talk about line plot in a minute. So to plot the relationship between, so here, if we don't specify the x-axis, okay, and we are here passing the whole data, and then we are plotting every attribute with respect to the indices. Okay, the index is the x value. Okay, the index is the index is the x coordinate, and we are plotting each one with respect to the index. So we're going to plot the value of every one of these three columns here with respect to the total score. Okay, so we're not passing X or Y, we're just passing the whole data. So then we are the whole data frame. So then we are plotting the content of every attribute with respect to the index. That's it. Okay, that's one way to do it. Let's look at it. Okay. Yeah, let me run it and then talk about line plot. Yeah, here before changing the index, and here after making a total score as the indices. Okay, here when we created the new data frame, and here we made the column total score, we made it as the index. Okay, and here are the values of the other three columns. Here is the plot. Okay, as you can see, for every one of these three attributes or variables, we have the average line as well as this shaded area here. Why is that? Because for every value here for total score, that value can come from different differences. There's no one-to-one correspondency here. Okay, the same total score can be achieved by different differences. So the shaded area is like defining the range or the variance, and the solid line here is the average or the trend. Okay. Okay, so that's like the yeah, that's the line plot. So a simpler way to do it is just this way here. Okay, let me do. Uh, what's happening? Why it's not? Okay, here. So we just like create the figure, and we call this line 3 times, changing just the y-axis. So we are plotting the difference between math and reading versus total score, and on top of that, we are plotting math minus writing versus the total score, math minus reading, sorry, writing minus reading versus the total score on top of each other. That will do the same thing. This is the first one, and this is the second one. They are doing the same thing. It's just here we are adding more things here. We're adding we are defining the markers. Okay, so we see here the legend, but yeah, the pattern is the same. Okay, the figure, the content of the figure. Okay, so now what happens? Okay, let me comment this. What if we plot the scatter plot? Okay, now here for this scenario or this use case, line plot is better. Okay, because you can see, as I said, the trend or the average and the variance. Okay, but scatter plot, the dots will just be all over the places. Okay, so and you cannot make any. What happened here? Oh, what's this? Okay. So here, it's gonna plot every single dot, okay? And that it will be difficult to look, yeah, here. So you see all over the places. So this tells you how, in average, how the relationship is going, as well as like in terms of the differences versus the total score, and also information about the variance. Here, you still you can infer some about the variance. Okay, the last dot is here for a specific value, so there's high variance for that one, but the average information is difficult to infer from here. Okay, so we will stop here for today. Next time, inshallah, we will finish this topic, inshallah. Assalamu alaikum.